Good morning, guys. Welcome to day one of our math class online. I just wanted to go through our first lesson and review our notes and talk about a few of the questions that I need you guys to complete. So for 10.1, we're talking about right triangles and trigonometric functions. When you hear trig, it actually means triangle measurement, okay? And the Greek letter theta is traditionally used to represent the measure of an acute angle in a right triangle. All right, so let's talk about our trig functions. We have sine, cosine, and tangent. I want you to remember that by SOHCAHTOA right here. SOHCAHTOA. SOHCAHTOA. You can write this over and over for every single problem, but we need to remember SOHCAHTOA. And so what that means is when we look at sine theta is equal to your opposite side over your hypotenuse, okay? So that's our So we have sine theta, which is opposite over hypotenuse, okay? So cosine theta is adjacent over hypotenuse, and tangent theta is opposite over adjacent. So I want you to imagine wherever theta is, I want you to imagine yourself standing on or in that corner and looking at the triangle from that view. So if I were to do sine theta, I would want the opposite side, so it's over here, over the hypotenuse. Your hypotenuse is always across from the right angle, okay? You got to remember that because sometimes the hypotenuse does look very similar to the longer leg. So hypotenuse is always across from the right angle. So SOHCAHTOA, okay? So in our first example, finding trigonometric ratios, find the value of the sine, cosine, and tangent functions for theta. So we are going to find all three for this problem. All right, so if I want sine theta, I want you guys to imagine yourself standing right here on the theta. I need the opposite, so I look opposite, which is 15, over hypotenuse. So I look at my hypotenuse, which is 39. 15 over 39, and I can reduce that by dividing both by 3. So I get 5 over 13. For cosine theta, again, imagine yourself sitting right here in the angle, and I need the adjacent, okay? So this is where it gets tricky. This is always your hypotenuse. So for adjacent, you want to look at the side that's right next to it. So you have 36 over the hypotenuse, which is still 39. So I have 36 over 39. We can reduce that to 12 over 13. And then when we look at tangent, okay, again, we are standing in the corner of theta, and we need the opposite, which is 15, over the adjacent, which is 36. And you can reduce that to 5 over 12. All right. Next, we're going to look at special right triangles, okay? So special right triangles, we have two of them. We have a 30, 60, 90 triangle, and we have a 45, 45, 90 triangle, okay? So they both have right angles, okay? This one is a 45, 45, 90 triangle. So your legs are identical, and then your hypotenuse would be a leg times the square root of 2. So 1 times the square root of 2 is just square root of 2. For our 30, 60, 90, here's our 90, here's our 60, here's our 30, okay? So the short leg, okay, your hypotenuse is going to be double the short leg. So if this was 2, your hypotenuse would be 4. If this was 3, your hypotenuse would be 6, okay? And then the longer leg is your shorter leg times the square root of 3. Okay, so 1 times the square root of 3 is square root of 3. If this was a 2, it would be 2 outside and then the square root of 3. So 2 square root 3. So we are going to make a chart, okay? And we're looking at these triangles. So if I want to know what sine of 30 is, okay, so I'm going to stand in the corner with a 30-degree angle. Okay, Now remember, sine, SOHCAHTOA, is opposite over hypotenuse. So it's opposite 1 over the hypotenuse 2. Okay? Sine of 60. So now I'm standing here at the 60-degree angle. Opposite would be the square root of 3 over the hypotenuse of 2. Okay? Cosine of 30. So we're standing here. Remember, ca, adjacent over hypotenuse. So you're going to have the square root of 3 over 2. Cosine of 60, we're standing on the 60. Okay? And we are doing adjacent over hypotenuse. So it's 1 over 2. And then for tangent, it's TOA, so it's opposite over adjacent. Okay? So if I stood at the 30, it would be 1 over the square root of 3. But remember, in our Unit 5, we cannot have a square root in our denominator, so I have to get rid of it. So you are going to multiply by the square root of 3. Remember, this is a square root. I need 2 numbers. Okay, so I'm just going to multiply by another one because I have 1 3, here's another 3, and then my square root becomes just a 3, and I have to multiply the top, so I get square root of 3 over 3. For tangent of 60, again, you stand here, and you are going to do opposite, which is the square root of 3, over the adjacent, which is 1, which you can just write as the square root of 3. Okay, so the 45s are on this triangle, and again, we're going to do the same thing. Because they're the same, it doesn't matter where you stand. So if I stood here at the 45-degree angle for sine, I'm looking at the opposite, which is 1, over the hypotenuse, which is the square root of 2. And again, we can't have a square root in our denominator, so I'm going to have to multiply top and bottom by square root of 2. So that gets rid of the square root on the bottom. It becomes a 2. So it's square root of 2 over 2. For the cosine, okay, that's ca. That's adjacent over hypotenuse. So adjacent would be 1 over the hypotenuse. So again, I'm going to get the square root of 2 over 2. And then for tangent, it is opposite over adjacent. So I have opposite of 1 over 1, which is equal to 1. All right, some things to remember that I put in my notebook, okay? So when we talk about the 30, 60, 90 triangle, the hypotenuse is always going to be double your shorter leg, okay? So this is going to be 2, okay? The longer leg is always the shorter leg times the square root of 3. So it's 1 times the square root of 3. Now, when we look at the 45, 45, 90 triangle, the hypotenuse is always a leg times the square root of 2, okay? So, the hypotenuse divided by the square root of 2 is equal to a leg. We're just going opposite. All right, when we are trying to find side lengths of special triangles, we're going to use the trig function to find our x, okay? So for this one, okay, you ask yourself, what information do I have, okay? We always want to stand where the theta is, okay? An acute angle inside the triangle. A 90-degree angle is a right angle. It's not an acute, okay? So I would choose the 60. So if I stood at 60, what information do I have? Well, I have the opposite, which is x. Oh, sorry. Where am I? Yes. Okay. Let's turn it this way so we can see. I try to draw it like they did in the book, and they have them all different ways. Okay, so 60, the opposite is x over 100. So what you have to do is you have to do sine 60 equals x over 100. Okay, so you just fill in the opposite over the hypotenuse. Okay, so we're going to substitute the square root of 3 for sine 60 degrees. Okay, this was from the chart that we just did. You can also do this in your calculator. Okay, so if you were to do this in your calculator, how do I get x alone? I'm going to multiply both sides by 100, and in your calculator you can do 100 times sine of 60, and that will give you 50 times the square root of 3. If I were to actually do this in the calculator, I would get the same. You'd get a decimal, okay? All right, so 10.1, I want you guys to do 1 through 7 and 15 through 18, okay? So, number 1, let's just look over it. The ratio of the length of the opposite leg to the length of the adjacent leg of an acute angle of a right triangle is going to be the tangent, okay? So what did I look at? Opposite and adjacent. When I have an O and an A, it's TOA, so it's the tangent, okay? So for number 2, I want you to find the sine, cosine, and tangent of this triangle. So again, sine theta, I'm standing on the theta. Sine is so opposite over hypotenuse. Opposite is 12, hypotenuse is 15. Remember, hypotenuse is across from the right angle. Okay, cosine is adjacent over hypotenuse. So I stand here. What is my adjacent? Okay, it's going to be 9 over the hypotenuse of 15. And then the tangent of theta is TOA, so it's opposite over adjacent. Okay, so I have the 12 over the 9, and you can reduce all 3. All right, they are all the same. Let's go over to number 5. And look at number 5. Okay, use a trig function to find the value of x. So here I want you to say, okay, I'm standing at the 30-degree angle. What information do I have? Okay, so I have the hypotenuse, remember. Across from the right angle is your hypotenuse. And I have the adjacent one. So if I have the adjacent and the hypotenuse, I want you to say, okay, SOHCAHTOA. TOA. Which one has A and H? It's CA. So we're going to use cosine is adjacent over hypotenuse. So our theta is 30. So we're going to do cosine 30 equals 50 over x. And I need to get my x alone. Now, by using the chart we just created, I know cosine 30 is equal to the square root of 3 over 2. You can also do this in your calculator. Okay? So if I were to do this in my calculator, okay, I am going to multiply both sides by x, and then I'm going to divide both sides by cosine of 30. So in your calculator, you're going to have 50 divided by the cosine of 30, okay? Using the chart, you get 100 times the square root of 3 over 3, okay? So if I were to work this out, that's what you would get in your calculator. You'd actually get a number, okay? So that is 6 and 7 is the same way. Now, let's go over and look at number 15. Well, they're the same, okay? So 15 is just like 2, 3, and 4. You are going to find the sine, the cosine, and the tangent, okay? And then 16, you're actually going to find the x. So we're going to stand at the angle and say, what information do I have? I have adjacent over hypotenuse, okay? So adjacent over hypotenuse is CA, so it's going to be cosine. All right, let me know if you guys have any questions. Have a good day.